Hello and welcome, developers. My name is Shay, and this is another episode of Shay Develops. Today, we're going to be learning about integers. And you might think, yeah, sure, just one single integer. But we're going to be learning integers on C#. And there's actually three different kinds of integers on C#. We have a 16-bit integer, a 32-bit integer, and a 64-bit integer. And really the difference of those is how much space they take up. So, you don't always necessarily have to use like a long or an int. You could use a short. So let's write a little comment here. So int 16-bit integer is a short. And a 32-bit integer is just an integer, int. And we have one more, int 64 is a long. So let's go ahead and create some values. Let's do short. Let's find all the minimum and maximum values of our three different int types to show you the main difference here. So in order to do that, we can do short dot min value. And do short dot max value. And we can do int min and max same way. And the last one is long. We can do that the same as well to get the minimum maximum value. Now you see these min and max value. There are methods that are built into C# that allows us to do some just a few minor things with our integer values. And a lot of data types and stuff like that in C# comes with these pre-built methods, or at least some of their own. You're not going to have a min and max value for your string. But strings are coming on another video. All right, so let's go ahead and get the long dot max value. And now let's write all that out. Right line. And do short. And we're just going to put in the min and max value. So short min. Nope. Let's do min here. Goes to. Oh, did not mean to open that up. Oh well, alright. By the way, I record these things just on the fly, not a whole lot of editing involved, just natural. So you'll see mistakes, you'll see me mess up, and that just goes along with programming. I mean, it's just what happens. I didn't start, knowing all this stuff. I had to fumble through it for a lot of the times. So here's our short. Let's go ahead and save this. And let's do our int and our long. And you may be wondering why I'm using this notation with the $sign and the curly braces. And that's so I don't have to concatenate my strings within my right lines and then separate out all my variables. So if I didn't have to do this, I'll do one the other way. I would have to do this right here to get this to work properly, and actually get rid of these curly braces. So you'll see this will print out the same thing as these are. It's just a little bit more, it's not really difficult to write, but it's I just like the other way better. And you'll find reasons why as we go into the string, the video on strings later on this week. Alright, so instead of this shorts though, I need to now fix our value, or fix our variables here that are being outputted. I've actually already recorded this once and didn't hit the record button. So, you know, lots of mistakes tonight. All right, so let's go ahead and run this. And we'll see that our short goes from negative 32,768 to positive 32,767. And then our int goes from negative to its positive counterpart. And I did not add a spacer in between that. Let's fix that. Okay, so let's run it now. Okay, so now you can see it's negative and positive counterparts as well. All right, and there's also a way to get rid of the negative counterparts as well. So let's keep these, the short, int, and long. We can also prefix these declarations with a u, and that allows, well, it starts throwing some errors because it doesn't like it, but we can input a u in front of these as well, and this allows us to no longer use negative numbers. It'll only accept as a positive number. It still takes up the same amount of space. It's still a 16-bit integer, a 32-bit integer, and a 64-bit integer, and it takes up the same amount of space. But it, like I said, doesn't allow negative numbers. So it's going to go from 0 to no longer 37,000 and whatever for a short. It's basically going to double that, and you'll see that here in just a second. So now, let's say we go from 0 to 65,535, basically doubling what it would allow to in the both negative to positive range. And it does that with all of them, the short, int, and the long as well, just by prefixing our stuff with u. Alright, so I was talking earlier about these min and max values, these methods that you can run on your data types, and there's a few more that we're going to talk about as well. But before we get into that, let's also talk about how you can save integer values that aren't necessarily integer values. And these are called literals. So go ahead and make a little comment here, literals. And let's comment out all this, so we can start talking about our literals. So let's do int, we have two different kinds of literals. We have hexadecimal and binary literals. So let's start by a not literal, make it equal to 42. And this will be a hex literal. We'll make it equal to 0x2a. And you'll notice we're not going to get an error here. Or if I was to just keep putting on the a's, well, it's still in hexadecimal. Hold on. Let's get rid of that to no longer make it a hex, and we get an error with our non-integer values. And we don't want that. But if we have it now, this is a hex value. And then we have one more, binary, right? Binary literal, and that is just our ones and zeros, right? So if we were just to do 10 10 10 10, I think that's enough ones and zeros, maybe one more. Anyway, it would literally print out 10 10 10 10 in this format. But if we were to put a 0b in front of it, it is going to print out the binary value of these. So let's see what happens when we console.writeLine. So let's first, we'll do not literal. Go ahead and make some copies of that. This will be our literal hex. And this will be our binary literal. Our binary literal. Alright, binary literal. Let's actually change this around so it's a little bit easier to read. Alright, so let's see what happens. So, our not literal was 42, like we put already, right here. And then our hex literal, 0x2a, is 42 as well. I totally did that on purpose, promise. And then our binary literal is 341. So say I was to get rid of this 0b here and then run this again. So we'll notice we're just getting the literal value of 10101010, which actually I guess isn't a literal in the same sense. But we're getting the integer value that we gave it. So just put the 0b back on front. Now, say you wanted to be able to read this a little better, you could use underscores in our binaries to separate out each 4 digits. And then that will actually output the same. It actually won't print out 341 anymore. Since I removed one, it'll be a slightly different number, 170. Yeah, that one right there took out a whole bunch of digits there. So now our binary literal has now, like I said, is now 170. Like I said, if we remove these, do it again, it's still 170. Alright, so that's literals, basically just saving integers as their non-integer counterparts. The next thing we're going to talk about the methods that we can use on our integers. Particularly compare to, which allows us to know if a value that we're comparing our integer to is higher, lower, or equal or the same. And that'll output a -1 for lower, a 0 for the same, and a 1 for higher than. And equals kind of does the same thing in a different way. It doesn't tell you if it's higher or lower. It just outputs a Boolean true or false value if it is equal to or not equal to. And then the last thing we're going to, actually no, that's not the last thing, I lied. We're going to go over 2 more. We're going to get the type codes, which will tell you what kind of integer type that you're working with, int 16, int 32, int 64. And then we're going to convert our integers to strings, and then we can convert our strings back to integers. So let's go ahead and comment out all these literals here. And we are going to talk about the compare to operator here. So say we have int first value equals 12, and we'll do int second value equals 451. And we wanted to compare these two values to see, you know, like, well, what I told you, is it higher, lower, the same? So we can easily do that with a, I'm just going to output it here. So that's what I'm doing, the console.writeLine. By doing, so we're going to compare the first value to our second value. And we're going to see if the first value is, obviously the first value is lower, we can see that, but to say this was user inputted data and we didn't know. We're going to compare it and see what we get. We get a -1, meaning that 12 right here is lower than 451. But if we were to flip these, we should get a 1, meaning that 451 is greater than 12, and we do. We get a 1 right there. And maybe I should use that rather than that dash, because somebody might get confused and think, but that's a -1, but it's really just a 1. All right, and the last thing, we're going to see if the two are equal to each other. So we're going to test if 451 is equal to 451. Run that, and we get a 0, meaning yes, that those two are the same. Now, like I said, the one that is very similar, we're going to go ahead and comment this one out so you guys can see it. Is equals. Yep, that's how you spell equals. Equals. So we're going to compare the two values to see if they're equal to each other. And this is only going to return a Boolean value of true or false. So let's do first value dot equals. Oh, it's a fist value, not first value. Dot equals second value. Now this definitely shouldn't return true. It should definitely return false. And it does. Boom. False. But now we can test. Let's see here. Our first value, see if it's equal to 12. And we get a true. It's definitely equal to 12. And that's it for equals. It's pretty simple. And so is compared to as well. And now this one's going to be a little more difficult, but it's still fairly easy. We're going to use our first value here, and we're going to convert it to a string. And then we're actually going to take well, actually, let's not even do that. Let's go ahead and comment these out as well, because we don't need them anymore. We're going to take a string of number, and we're going to give it a value of 32. Now this is a string value of 32. So if we console.writeLine and we get its type, which we haven't talked about this yet, but this is now a pretty good time to get the type code to figure out exactly, I said, what we're working with. I'm going to write that. We'll show you. We'll see number dot get type code. And that's giving me an error because I need some parentheses to run the method. There we go. Now, get type code is a method that comes with a lot of your data types. It comes with integers, strings, your floating point values, stuff like that. So now we should see string get output to the screen. And we do. Get code type string. Now say we wanted to convert that string back to an integer. We can do that by parsing. So we can parse our number. Actually, that's not how you do that. You do an int 32. So we're going to use the type that we want, which is an integer, a 32-bit integer. We're going to parse it with the value of, we're going to parse the number, and then we're going to get the type code back of what this is. And this should be an int 32. And it is. Yay, it worked. And you can also do some stuff like, you can, once you like say you wanted to add 1 to your string of number, it would just put out 321 rather than 33. I say I can show you that now because it's not saving this. Like, it's not like we're modifying number to no longer be a string. It's just not being a string in this particular instance, this reference call to it. So if you wanted to make it to where it was no longer a number, you would want to take this value, or take this code here, create another int, and we'll save it as converted number. We actually don't need the get type code here. And we outputted converted number. Boom, we're back to 32. Okay. But say I wanted to add 1 to this number, right? I can do that, and now it's going to be 33. Oh, I lied. It's not 33. Let's do a little math. So your converted number plus equals 1. Now this should be 33. There we go, 33. But to say we wanted to add number plus equals 1 and then output the string of number, we're going to get 321. Oh, we have some errors. Gotta fix them. Oh, extra parentheses there. All right, try that again. Now you see that? Yeah, we got 321. And then now, since number is 321 and we add another 1 to it, we get 322. Hopefully that makes some sense. If not, let's go over it again. It's a little, let's say, convoluted, but you know, it's definitely has some practical applications out in the real world. All right, and the last thing we're going to do is just simply convert our number, converted number, back to a string, and then we are going to output it so the internet believes me. So the last thing we should get, converted number to a string. Oh, dot get type code. And boom, it's a string. Alright guys, hopefully you found this video useful, helped you learn a bit more about integers and how they work in C#. If you like the video, please give it a thumbs up, subscribe, click on that notification icon to get notified whenever I post videos. I try and post at least one a week, if not more. I do this not only to help myself understand the content that I'm currently going over and learning, but to help others who are, you know, trying to become developers themselves and understand this, you know, a bit more. I know whenever I was first starting this stuff out, it was a bit difficult, and I have read over countless documentation, watched countless videos, trying to understand some of this stuff, and then not being able to understand this, that, and the other for whatever reason. And you know, finally I found a video where something clicked and it helped out. So hopefully this will do that for somebody out there. All right, so if there's something though that you guys are struggling with, you want to learn, some constructive feedback that you want to give me, please put that in the comments. I'll get back to you as soon as I can. And I hope you guys have a great day, night, week, month, year, and I'll see you in the next video. You guys take care.